My name is Spencer Walse. I'm a research chemist with the U.S. Department of Agricultural Research Service in the San Joaquin Valley, California. I am a chemist who's primarily interested in how molecules play a role in agricultural, ecological, and environmental systems. Currently, my position is focused on post-harvest treatments to target insect pests that are inhibiting our ability to move food domestically from one state to another. I think perhaps more importantly, though, these post-harvest treatments are in place to prevent microbial contamination from spreading and/or infested food from moving through these geographic areas and/or political boundaries. One contemporary example of how integrated pest management programs interface with post-harvest treatments can be drawn on in the case of the peach twig borer, which is a pest of peach, plum, and nectarine in the San Joaquin Valley. For years, growers in California have been trying to export to trading partners that were very wary of this pest being introduced into their countries. We worked for years to develop trapping and monitoring data to demonstrate not only what the incipient populations were in the field, but moreover, how agrochemicals could be used and minimized in an attempt to prove to these trading partners that peach twig borer, or PTB, was not present at levels that should concern them or pose any risk to them. Finally, some trading partners agreed to approve this systems-based strategy, or strategy that incorporates many features of integrated pest management into the trade plan. And unfortunately, the trade was eventually derailed by the introduction of a new invasive pest, the spotted-winged Drosophila. And this has been very unfortunate, and clearly it shows how integrated pest management can be very beneficial and can improve our economic trade capacity and economics associated with it. But it also points to how integrated pest management and strategies are continually evolving, and how they cannot simply be focused on just one species and just one scenario. They need to be flexible, they need to be modulated, really to control any of the pests that are in the field, whether they be new or old. Therein lies a grand challenge associated with IPM. It's in place to ultimately reduce the necessity for not only agrochemicals in the field, but also decrease a reliance on post-harvest treatment. Now, at the same time, we need to be constantly fine-tuning it. Species-specific research needs to be conducted so that it can be implemented as effectively and as efficiently and as universally as possible. Because integrated pest management strategies are often very difficult to successfully implement in the field across large geographic areas, we have many challenges ahead of us. From a post-harvest treatment perspective, one of the goals that my research strives to attain is integrating IPM strategies so that with post-harvest treatments, so that we can ultimately reduce the requirement or reliance for standalone post-harvest fumigations. Post-harvest fumigations no doubt play a critical role in preserving the environmental and ecological health of importing countries, but at the same time, through an increased awareness and understanding of what's creating the pest problem out in the field, we should be able to rely on them less and less. In summary, integrated pest management is a critical feature of contemporary agriculture. There are many examples which we can improve on and build on. Ultimately, at the end of the day, if we continue to understand the system where pests are impacting our agricultural productivity, we will be able to more efficiently and more sustainably control all of the harmful impacts on environmental and ecological health that stem from the use of chemical treatments.